a breakpoint instruction. So that's just one of those things that you try to remember. And on top of that, it told me that I reached a software breakpoint. In order to actually define an instruction there, I actually pressed the C key, and that defines the function, or the line of code here. So this is somewhere in the middle of NTDLL's address space. If I scroll up above, I see some referenced address. This is actually probably the beginning of a function. So when you're dealing with obfuscated code, you're going to see a lot of this stuff where at some point there's just a bunch of random bytes. And you might see little chunks of code here and there. That's because IDA didn't define this for one reason or another. The only reason it defined this guy here is because, or it was actually, so it had a couple instructions defined here, is because it broke here. So otherwise, this would have been just a bunch of random bytes too. You could get it to not do this. That would exclude you from using software breakpoints. So the way this works is if you actually, I believe if you set a breakpoint, but you tell IDA that it's not going to handle software breakpoint exception, then it's not going to ever stop on your software breakpoints. So when we created this one here, that's actually a software breakpoint. Let's take a look. So by default, all exceptions are handled as a stop. The debugger handles it. You can actually tell IDA to pass it to the application versus to the debugger. So basically, IDA's controlling the whole execution of this thing. And when the operating system sees the int3 instruction, it says, well, this is a breakpoint. I've got this table of information. It tells me what to do in the case of any particular interrupt. And so IDA says, I want you to call me every time I hit an interrupt, by default. And this exceptions window here, it's under debugger options. And then you click on edit exceptions. This allows you to change which exceptions that IDA says, operating system, you make me in charge of that. I'll handle it. So otherwise, when you're just running this program and it hits that int CC, it's actually not going to do anything. It's gonna just keep going by. It's going to say, just an int3. I don't do anything here. Continue the program. So you could actually put a CC instruction in your code, and it's not going to do anything unless you're debugging. So. Thank you, Veronica.
You're welcome.
Veronica was just suggesting that while we're on the graph view, oh wait, why do I? Do you all have in the graph view? Do you have addresses?
No.
Okay. I don't remember enabling them, which is really weird. You can actually. So while you're in the graph view, oh, you know what? It's because I'm in the debugger. So when you're debugging, it displays them at all times. But in the regular view here, you can actually choose to display the addresses if you'd like under Options, General, and there's line prefixes, and that gives you the addresses. Now, I'll let you guys decide whether you want to use it or not. But it might help you if I call out an address, then it's easier to find it. And this should be a pretty short one. So I saw some people had things labeled differently than me. The function that's called before printf, but after each phase is this secret phase. We're actually not going to cover that in this class. That's kind of for you guys to do on your own, and you're more than welcome to ask me questions about it. It's kind of, if you want to keep playing around with this thing, you're more than welcome. And my email address is actually on the About This Course page on the wiki, and I can write it up on the board at some point if you guys want it. But yeah, the secret phase should be the repeating function that's not input. And if you don't have input labeled, then let me know. So after phase 2, we've got, that's number 2, keep going. We've got call input, and we've got our next phase here. Actually, I'm confident that that's phase 3, so. So, in this part of the lab, you're going to be introduced to the switch case statement. That is, you'll notice that by a single block that's connected to a whole lot of other blocks and has this sort of instruction in it. Okay. So in this case, we're taking whatever's in this var18 local variable and throwing that in EDX, and we're using that as an index into some array. Okay. So basically, somewhere in memory, you have just a list of instructions or a list of addresses. Each one of those addresses corresponds to a block of code. And so you might use this if you have like a menu, for instance. So you want to have somebody choose from a series of options, 1 through 10 or whatever. This is the kind of thing that would be produced from a switch case statement. So the other thing is scope of analysis. So what are you trying to accomplish? Come up with a goal and stick to that goal. You're going to be faced with lots of different options, and at some point you've got to decide, when you want to understand all the code paths and when there are particular code paths that you want to follow. So some things to think about. So if there are any questions about where you're beginning, if anybody isn't caught up to how you get to phase 3, let me know. But we're going to spend the next, we'll probably go till, say I'll just give you until 1:30. It could be a character, for instance. So let's hit R. Now that looks like a T.
You do R to
Yeah, I already
show
had that.
a variable of a character?
Right.
Yeah, I already have that Google ASCII table ready. I already have that. I've already considered that.
Did it the hard way. So H will change it between hex and decimal, and if it's character, then it will change it to hex, and R will show you character.
Well, that's even easier. I was right-clicking because the menu also shows it.
Ah, yes. So right click,
Yeah.
it'll tell you what it's going to convert it to.
I didn't notice there was a keyboard shortcut attached to that thing.
Okay, I'm going to pick on somebody remotely here. I'd like to know what are the inputs to our answer here. What are we looking for? How about Scott? Do you have any idea? Scott, are you with us? Okay. How about Sam? You with us? Is anybody who's on? Okay. So Sam, can you tell me how many? What is the input that we're looking for this phase? Yes, the types of the number and whatever. What do you know about the input? Okay. It's okay. Hi. Oh, all right. Very detailed. One decimal int character, another decimal int solid. Okay. Well, that is right on. We're looking for 3 items. Once again, space separated. First one being an integer. Then we got a character. And then we've got an integer. Okay. And we've got some conditional statements, and we've got and then we've got the switch case. Okay. So, can anybody tell me where the first integer is stored?
Bar 8.
Bar 8. Okay. So, good guess.
I'm sorry. Bar D plus 1.
That's correct. So just like function arguments, the scanf arguments are going to be pushed on the stack backwards. So you start from right to left. You'll see we've got 5 push instructions before I call the scanf. And so the first one is bar 8. We load that in EAX, push it, and we load bar B, push that in ECX, or push that using ECX, and then bar D plus 1. So bar D plus 1, we could name this first int, okay? But the problem is now our character gets that same name. So, what can we do about this? Well, we click on our stack up here, and we do edit. No, I don't ever use the menus. There we go. Functions, stack variables, which is also Control K and Alt K will allow us to change the particular item. So if you hit Control K, it'll take us to our variable here. and we saw var d plus 1 in var d. So the reason this happened is we have an integer, which is a character started var d, and then 1 byte after that it begins an integer. But when IDA sees this, it says, well, everything being moved off the stack is 4 bytes, because everything on the stack is 4 bytes. Well, in this case, we're not really interested in all 4 bytes, we're just interested in one of the bytes. So I'm going to rename this input char. And I'm going to hit the D key, okay? Now you can see here, before it said DD, and there was only one item, and then one DB before var 8. Now I've got 5 DBs, including this line with input char. And if I click on the next line, which is going to be D plus 1, I hit D, D, and one more time, D. That gives me a double word, which is specified by this. So DD is data double word, DB is data byte, and DW is data word. So DD takes up 4 bytes, DW takes up 2, DB takes up a single byte. So now I can name var C first int.
So I do have a question on that. So it almost seems like the compiler later on, like 2 blocks down, deals with this problem.
Okay.
Right? Because if you go down just a tiny bit, you see this block where it moves that exact address of RD plus 1 plus EBP into ECX. Back up a little bit. And that block in the middle right there, it almost seems like it's dealing with it, and we have that extraneous var 18 up there as well.
Right. Right. So
that bothered me for a long time.
So let me undo what I just did here.
I actually like this more. I was just curious, like, is there a way that works better in IDA to deal with this kind of thing? Because like it took me a while to consider, like, wait a minute, this is the same damn thing.
Well, see, the thing is that we're talking about 2 different variables, right? So
right.
You have the variable that you were using with scanf, and then another variable was, so what probably happened here is we probably had an array of bytes, and we passed in offsets to that array of bytes to our scanf function. And then right here, once again, we used that array of bytes and moved it into this variable here.
Okay.
So it's going to look something like this. Anybody want to see this again?
It's almost like you wrote, like, you know, char 5, like, what, you know, my variable char 5, and then just interpreted it later as a char in it.
Right. So what you had was something like we had var d as the base. Is some like char array, and it's made up of 9 bytes. And then we probably said something like scanf. We've got input, and then we've got our format string, and then we've got so the first one was, I guess, right at RD, right.
We cannot see the whiteboard.
Bill?
Sorry.
No problem.
Oh yeah.
So it'd be something like this.
Okay.
So your call to scan app would be something like this. And then you'd have bar 18 equals, what did I say, it was this guy here, right? So
Yeah, that's the first thing.
and this is some sort of int.
Okay.
And there's some dereferencing going on. So you can, typecast is going on. So, so in a compiler, when you use something like a char array, then you want to treat something as an int. If I want to store something from a char array into an int, the compiler's got to understand that, and it will complain if you don't do something like this. So that you'd say. So that's actually what's happening. So which path do we go down? Does it matter?
Nope.
Okay. So each of these branches of the switch is just another possibility. So you put in a number that is, so it's checking to see whether it's above 7. Okay. If it's above 7, it blows up. And otherwise, it comes over here. So at that point, it uses the bar 18, which was our first integer, our first input, and you're choosing which branch you want to go down. So whether you give it 1, 2, 3, 4, 5, 6, whatever you give it, it will decide which one of these branches you're going down. And then, what are we comparing here? First of all, are these two instructions related? Okay.
Not yet.
Okay, so we're moving something into bar 1. We don't do anything with it. We just move this thing into there. And then we do this comparison. So bar 8 was our second integer, the third input in the string. So if I were to choose 0, I would come down to this right branch. And if we actually look at this, so I'm going to double click on this jump here. You'll actually see what this jump table looks like. It's just a bunch of offsets to addresses. It's just an array of integers, basically. So your first input is going to choose what offset within this array to use. So if I choose the first one, I'm going to store 71 hex, which is actually the letter Q. And then I'm going to compare our second integer, our third input, to 309H. And as I mentioned before, 309H, you press the H key, and it converts it to decimal. So 777 is what we're going to put into our input string.
How do you change that to a Q?
What's that?
How do you change that to a Q?
Okay. Josh is asking how I change bar 1, this line here with bar 1, 71 hex here. Click on the 71 hex, you'll see it highlighted, and then press the R key. so if your string was something along the lines of 0, some character, 777, then we move on to the next step, bypass the bound explode. And this is where all the switch case paths merge together. So they all have this jump instruction to say, okay, now let's get back to the main branch of code. And we have var1, which we start up here. Which is the correct character that we're supposed to input. And we compare that with our input chart. And should get us past this phase. So did everybody come up with an answer for this phase so we can move on to the next one? So questions about this? Did you have a question?
Well, first of all, is there a go back because I deleted something to rid of the data?
Okay, I will help you as we start the next phase. Yeah.
So when I was doing the compare, so at the one step where we were supposed to compare to an integer, it kept failing the comparison, which I didn't even know why, and I had the right third integer.
Do you have a new line at the end? Because it cuts the last character off.
So in your input file, if you're using the answer file,
because if it gets EOF right after the 4, it says, oh, I need to cut that last char because it's a new line.
exactly.
And then you read 52 instead of 524, for example, to use the last branch.
So this is something where if we had thoroughly analyzed the input function, we would have realized this. The last character, as he said, is taken off the end. It's assumed to be a new line character. And so if you don't put a new line at the end of each line, then it won't work properly. It'll assume that you got the wrong answer. And you can have any number of spaces. So if for some reason you wanted to, space out your answers, that's fine. You can do that because it does a loop, and if it sees that it's got an empty string, so it's going to read this in. It's going to remove the new line. And then say it's got no characters in the string, it's going to keep trying to read the next line. Okay, so end of phase 3. I'll deal with your question, Josh, after. Any other questions? Okay. So we press G and go back to main. Use our graph overview or scroll down so we get to the end of phase 3.
Okay, now it worked.
There you go, that was it. We've got phase 4 here. Okay, so in this phase, this might be a situation where you'll actually potentially want to use scripting. Let you know that ahead of time. You can try to do this by hand, and it's definitely doable. But this is a situation where having some sort of code is helpful. Actually, you don't have to even run it, but if you trace what's happening and you write code, some sort of pseudocode, it might help you to understand it. So just a suggestion, if you have any questions about that, because you're not typically writing code, I can kind of give you ideas of the thought process or how to write some sort of code-like thing to trace what's going on. But you're going to see recursion. So what do you expect to see? Veronica, what are you going to see? Inside our function, we know it uses recursion.
Okay, I just don't get the question. I saw the recursion and what was the question?
Okay, so we're gonna start
Right.
the bomb lab phase 4, okay? And it uses recursion. So what do you expect to see when you enter the
Calling
function?
itself? That's what you're asking?
Right. So you'll see the name of the function
Inside
at the
the
top,
function,
and then
right.
you'll see the name of the function again somewhere in the flow of the code. Thank you. Perfect. So we open up phase 4 here, and we don't see any recursion yet. No call to phase 4. How about this call right here? You see when I immediately entered the function, the name was highlighted, and it was also highlighted in the middle of the code. Okay? So this is classic recursion in code. So this thing is just going to keep calling itself and doing something with the input. So have at it.
I think we're making up each time to each counter.
Okay, so we have 2 calls to this recursion. And one is down the branch where we've accumulated everything, and one is down another path. So we keep this up. So who knows what number would have worked so far? So not necessarily the greatest approach. So next thing I can do is go ahead and try to work this out in code. Now, if you've come up with a debugging approach that you like, feel free to bring it up. I like to do things the hard way.
Do any of the newer versions might have conditional debugging or conditional breakpoints?
Actually, this version, actually, if you right-click the breakpoint, edit, we actually have the ability to put in conditions here.
Oh, okay.
Yep. So let's write some pseudocode. All right. So this function takes in our input integer. Okay. No, for simplicity, I'll call it x. Okay. And at the beginning, we check to see if it's 1. And if it is, if it's 1 or less, we go to the left. So we're checking to see if x is greater than 1. If it is, we take our input, subtract 1 from it, and we pass that to the recursion function.
That was off.
Reinforcement jumps.
Yeah. That's actually what I would have
Okay. So we store that into ESI. Call that S. Yeah. Let me call it Y.
done.
And then we do what next? What do we do after the first call?
Y plus closure protections too.
So let's say, yeah, that works. You could write this one of many ways, but then we go ahead and run this thing with x minus 2. So if the value was 2, come into here, x is greater than 1. Okay, 2 is greater than 1. So recurse 2 minus 1, 1. So because we know recurse 1 is 1, and recurse 2 minus 2 is 0, recurse 0 is 1 equality. So we know recurse 2 is equal to, all right? So recurse 3 is, what is recurse 3? Just looking at this.
Great.
So it's going to be recurse 2 minus recurse 1. And then recurse 3, or recurse 4 is going to be recurse 3 minus recurse 2. And so on. So rather than doing all the iterations, we get 4, 5, 5 is 8, 6 is 13, 7 is 21, 8 is going to be 34. So it's going to give us 21 plus 34, 25. So by writing some code and then doing the first couple iterations, we can figure out what is the answer. So any questions about that? Did I take that too fast? Any questions online? Okay. And yes, Andrew was just saying if we start out with a low number in the debugging, then we would have a better idea of what the result was, because we wouldn't be doing all those deep recursions. All right. That's all. This is actually close to the time I want to break. Does anybody want to continue on, take a break now, or go through one more of these?